Thank you so much for having me today in this wonderful conference, AI for Education. My name is Samir, and I'm the director of the Air Traffic Management Research Institute at NTU Singapore. ATMRI is a joint research center between the Civil Aviation Authority of Singapore and NTU. And I'm also a professor of air traffic management and artificial intelligence. And today I'm going to share some of the exciting things that we are doing at the Institute. We are also run courses for undergrads, especially on air traffic management. So our student controllers come to the lab and run scenarios and try to do sandboxing. And then we are doing it for several years, actually. And then we observed something. And that's what I would like to share with you. What were the challenges that we faced and how we overcome that in the Institute. So the first problem that we faced was this theory-practice transfer gap. Okay, so we know that this is one of the challenges that we face in the traditional classroom-based instruction, right? How to translate the theory effectively to the real-world operation. Air traffic control is a very hands-on kind of, learning experience. And when we teach in the class, the theory, students find it very difficult to understand and comprehend. So that was the one challenge, that the knowledge, the abstract knowledge that we transfer to the student in the class, we were not able to integrate with the operational experience. So that was challenge number one, the theory practice transfer gap. The second challenge that we faced in air traffic management class was about the comprehension bottleneck. This is something which is very critical in learning complex skills. So what happens is that in this particular comprehension bottleneck, a person can perceive individual concepts, but is unable to bring all the concepts together in order to form a bigger picture. So the students were able to understand the air traffic procedures, the separation requirements for the traffic, the safety concerns, the controller-pilot interaction, but they were not able to understand the overall safety comprehensive information flow in a complex airport kind of operation. So that was the second problem I faced. The third one, of course, is the real-time feedback. So the student is a big class, and when the students are doing so many hands-on activities, it was very difficult and challenging for me and for my tutors to give feedback to the student, what they are doing is correct or what's is not going very well, right? So then a few years ago, we came up with this particular idea that I'm going to share with you, which is based on this convergence that we are having in these three important areas. The integration of artificial intelligence, digital twin technology, and mixed reality. We thought that this is going to be a new paradigm for us to redefine the education and the training in a complex, safety-critical operational environment that we do. So, and you all have heard about AI and digital twins a lot, but I'll just first quickly give you a context about the mixed reality. So you all know the mixed reality is something which consists of three different type of component, which is augmented reality, virtual reality, and the mixed reality. So in virtual reality, you must have played games like this, which VR based, and it calculates and creates a digital environment which you get immersed in, and this replaces the real world, right? And then we have the augmented reality. For those who are playing Pokemon Go game knows this very well, that there's an overlay of the digital information on your real world, right? And then comes the mixed reality. So mixed reality is basically something very interesting. It blends the digital objects with the real world. And that's what we want to leverage upon. And I'll talk a little bit. So the challenge that we had about this mixed reality is how to bring and blend the physical world, which is airport and air traffic procedures and operations, within the digital world. So let me try to explain this a little bit, that how we have combined these three technologies, AI, digital twin, and the mixed reality in our air traffic management training, simulation, and analysis. So this is me in my laboratory, and you can see this is the first case study I want to share with you. So we have a 3D printed airport, as you can see. It's a Lego kind of pieces that we brought together. And we can see it's for Singapore Changi Airport. These are the two ATCO students that are wearing HoloLens and interacting in a augmented reality environment. And ATM is a mission critical system actually. It has very diverse stakeholders, including airport operators, ANSPs, air traffic controllers, aircraft operators and all that. And in order to build a scenario for simulation and training is very complex, right? It's very challenging. Controllers have to tell to the engineers what they want, what kind of scenarios they want to play with, experiment with, and then engineers have to spend hours, working on the careful scenario that will unfold. It's a very handcrafted exercise. So the fun is taken away because the engineers exactly know where the two aircraft are going to conflict on this particular taxiway. So the emergent behavior that we see in air traffic is not there anymore. It's already handcrafted and pre-engineered. And controllers also know that, oh, there is somewhere the conflict is going to happen, and they just want to anticipate. So the fun of training and feedback is taken away from this environment. So this was the challenge that we were facing. There was a limited collaboration and stakeholder engagement, and the simulation setup was very time intensive and very complex. So our solution was to come up with the artificial intelligence and mixed reality digital twin that you see on here for this mission critical system. So we integrated a large language model with the mixed reality digital twin. So this digital twin that you see is a 3D printed airport airside operations, which has runway, taxiway, gates, and all that. It's mixed reality because the entire, as I'll show you in the subsequent screen, how the student controllers see this environment when they wear the HoloLens, and how the two controllers have a shared visual space in order to collaborate and sandbox various concepts in that. So this particular technology, there's a very interesting user interaction flow. It is very intuitive and straightforward. The controllers don't have to tell to an engineer that they need a particular scenario. They can just speak, right? They can just say, for example, here, they are just giving an instruction to an aircraft to be created at a particular gate over here, as you can see in this one, and to go to a taxiway and go to a runway. I think in the next one. So here the instruction was given as create an aircraft at Whiskey 4 and move to gate number C15. An aircraft has just landed, and just by speaking these prompts, the simulation is automatically created and the aircraft follows the simulation. I think in this one there is a small video, if it is working. Yeah, so this is a first person view where the student controller is interacting using large language model and giving prompts such as create an aircraft at Whiskey 4, which is the runway exit at Changi, and move this aircraft to gate C15. So when they speak, the prompt comes and they accept and the aircraft starts to move. As you can see, this is how they see in the HoloLens and the physical overlay to the 3D printed airport. This is, as you can see, this is a 3D printed airport and this is the digital overlay. They can see various prompts for conflicts that can be happen. This allows different controllers sitting on the either side of the table to interact with each other, to do sandboxing, to evaluate various options to take an aircraft from one gate to another runway or taxiway and all that, right? So this particular benefit that we have gained is about combining the digital twin and the AI and the mixed reality. We moving away from complex and rigid scripting of the scenarios, right? Controllers can be immersed in a dynamic simulation environment and they can control this with natural language interaction. So this is, of course, very cost effective. Right now, if you use a air traffic simulator, it's like $1,200 an hour usage. But with this setup, we were able to cut down upon the simulation training time. Controllers were able to sandbox various complex scenarios about runway closure, taxiway closures, or aircraft accident or incidents that are happening. And they can just talk naturally with each other. And these instructions are converted into from the text to visualization to the route that they see on the taxiway. So this was the first experience or first case study that we did with our student controller to have a natural language interaction with a digital twin environment using augmented reality. The second case study that we did was a AI-based knowledge assistant. Remember, we have one controller sitting on the one side of the table, other controller sitting on the other side of the table. And they both were having shared visual interactive space, and they both were interacting with each other. Now what we did is we removed the second human controller and we brought a avatar, right? Or a digital AI assistant. Now this digital AI assistant has all the possible knowledge, 500-page manual of the Civil Aviation Authority of Singapore about taxiway procedures, safety regulations. There are 300 aircraft types, you know that. They have different separation standards, different taxiway have different, taxiway design group, which aircraft can go on which taxiway segment, everything is there. So the human controller was sitting on the other side and he was interacting with this virtual AI assistant about various scenarios. Can I take this aircraft from this taxiway to this route without, having an interaction with this coming aircraft? He will then advise, no, this is not possible. This will lead to congestion or runway holding and things like that. So this become a very, I would say, enriched learning environment for our student controllers. And they were able to, have a very immersive learning experience. In the old model, the students were asking, for example, what is the formula for lift or drag and all that, and AI gives them the formula. In the new paradigm, the students can ask that how can I make this plane faster? And the AI can advise them, why can't you try to modify the wing shape on the holographic model and to see what happens to the drag coefficient. So there is a immersive, interactive, and a real-time feedback available to the students rather than having going through a dry theory equation-based model. This is what we were able to achieve in these experiments. So this is what I believe is a very interesting future of learning with human AI teaming and active experimentation ecosystem. And I think this can lead to AI-enabled personalized training and learning and can set new standards, can lead to self-improving. Also, this provides for collaborative learning and experimentation. See, through this digital shared collaborative space, a controller can be in Singapore, the developer can be in Hong Kong, and the analyst can be in the UK. All have common shared interactive space. And then they can collaborate and can unbox new concept, new idea, which was not handcrafted by the limited understanding of an AI engineer or an air traffic engineer, right? So that's all I want to share with you today, and thank you so much.
Yeah, I always discover new things from my colleagues when you hear them present. That's so cool. Okay, any questions? I've seen some questions that's popping out here, but it's for other speakers. But any questions? Okay, maybe I'll ask one because I'm very curious. So which platform or LLM do you use to prompt that plane to appear on the screen?
So there is a base model, but we have developed our own large language models for this exercise. Yeah.
Okay.
So the research was recently published in Nature Artificial Intelligence journal paper,
Okay.
where we have developed our own large language model for this. Yeah.
Okay.
Because you see, the phraseology that is used in air traffic control is very structured and is a IQ standards.
Yes.
So normal large language model that are based on conversation cannot be used in an air traffic environment.
Okay.
Okay, so Charlie Alpha Zulu from gate Bravo, take holding point Charlie, and then take runway exit, blah, blah, blah. So this is a common large language model wouldn't be able to understand, interpret, or generate information over and above that. So we took 400 hours of air traffic voice data to train our model, actually large language model for that.
Okay.
Yeah, so it's a second layer of model
Okay.
based on LLMs.
And you have all the hardware you need to train that model.
Oh yes, expensive hardware. Yeah.
Okay. Another thing that I discovered from in my own backyard. Okay. Okay. So do you have a name for that large language model?
Not yet. You can
Not yet.
suggest one. Huh?
Okay, we will get the audience to suggest. Okay. Okay.
Okay.
Any other questions? Okay, so you have the extensive hardware, you can develop your large language model for your own specific niche area. Okay.
Thank you, Prof. Samir. It's a wonderful demonstration of this training for this task, right? It's a fantastic work that you have done. I come from the medical field where we have doctors diagnosing medical conditions, making decisions. Right? There are many different scenarios. So I was thinking whether can get your advice, right? How applicable do you think we can use this kind of scenario training with the AI simulation, right? To apply to different kinds of medical hospital scenarios, right? I think off the bat, right, a well-conscribed scenario could be, for example, resuscitation when a patient comes into the emergency department. Or another well-conscribed scenario could be maybe when a multidisciplinary team meets to talk about treatment, management, decision-making, and all that, right? But I also hear that you have had to develop a refined model, right? So tapping on your experience, right, if we were to take your idea and plant it into other professional environments, right, such as the medical ones I gave you, how difficult is it doable? To what extent? What must we look out for? Yeah.
Every profession and every field have its own lingo, as you have rightly mentioned, right? Their own, terminology that they used in their own profession and discipline. Based on the experience that I have in this particular domain, it took us around 4 years of research work, around 7 scientists working on it to develop a system that can be used in air traffic training programs. But I'm sure that with the hard work and efforts that we have already put it into this kind of system, adapting it to a new domain won't be a challenge, especially the scenario that you just mentioned, that there is a team of different specialists, right? An anesthesiologist, a other person, and they all come together on a common, table with a patient and interact with each other, experiencing and discussing various scenarios that can be, done for the patient. So I believe this kind of approach will be very impactful in medical training and medical simulation. So I think we can discuss and take this further. I can share the research paper that we have presented on this work, and we can certainly collaborate for sure. Thank you.
Thank you.